Pathway Worldwide. This is Andy making another video for you. Talking today about section 3.2, part A, and this is a question that all people have doubts about if they can do it or not. And I think one of the reasons why is just because it has shapes, and don't let the shapes scare you, right? The shapes shouldn't scare you at all. They're just trying to help you visualize what's going on here. Now, when it comes to area and volume have a lot of things in common. You know, if you look back on our formula sheet, you can see that the area and volume almost go hand in hand. One thing I like to do about this one, right, in this type of problem, is talk about kids in a bathtub, right? Because one of the earliest memories we have of bathtubs is filling it up all the way to the top, right? Because you want it as tall, as high as you can, the water level as high as you can, and then you get in, and then it starts overflowing, right? Especially if you know, two people get in, or you throw in all your toys in there or something like that. Then you start to have some of the water go out or overflow, and the reason why is because there's too much volume in there for that bathtub to take, and so the water is the first one to leave, right? And it's so eager just to go right over the side. That's kind of like what we're doing here. What we're going to do is just find the area of this area of the circle, and then what we're going to do is just subtract the area of the rectangle, right? So it's just as simple as that. So don't let this problem scare you, okay? If you are just needed that little piece of information, go ahead and you can do your thing. I'm going to keep going on and help you guys figure it out. Let's start with this area of the circle. In the formula book, in the formulas given in your book, we find that the formula for finding the area of a circle is actually A equals pi pi r squared, right? So you have area equals pi r squared. Now they didn't give you the radius, but they did give you the diameter. So to get the radius, all we'd have to do is chop this right in half, right? So 15 divided by 2, and we can go in here and it'd be 7.5, right, centimeters. So we can stick that in here, stick what we know, so 3.14 times 7.5 and 2 up to the second power. And if you do that calculation, let me get out my calculator real fast, and we'll be able to get that calculations. These formulas come in really handy. If you guys already haven't copied this formula page and just have it next to you, I would suggest you do that because it helps quite a bit. So 314 times, and we're going to do 7.5 up to the power of 2, and we get an area of about 176.625 centimeters squared, right? Inches squared because it's area. So that's our area of the circle minus the area of the rectangle, which is 8 times length times width, right? So 8 times 5, and it's just 40. Right, and we're just going to subtract that. So we get about 136.625. Okay, and then I'm going to go to the book and see if we got it right. And we are on problem number 5. Problem number 5 is 136.62. So one of the big deals about this is just visualizing it. Don't be scared of those shapes, and be able to plug in what you know for the formula. So that should help you out with this problem. Hopefully you've gotten some out of this video. Let me know in the comment section below if this video helped out. I sure hope it did. Until then, we'll see you later.